Hey everybody, Noah here with Learn Meta-Analysis, and in this video I want to show you not only how to calculate effect size using simple meta-analysis, but also run a conventional meta-analysis and all of the steps that go along with it in one video. Okay, so we are going to do this full tutorial of simple meta-analysis for conventional meta-analysis. If you've seen the channel and you've been around the channel, you've seen I've done this same walkthrough with how to do this in R. We're going to use the same data set today so that we get the same answers, and I'm going to show you how much quicker this is. So what I mean by that is I'm going to do all of the steps through publication bias testing using simple meta-analysis, and this whole video will most likely be shorter than the entire series is of videos on how to do this in R, simply because my whole point of simple meta-analysis was to make this easy, make this fast, so that you don't spend hours and hours coding. Instead, you can analyze your data and then really start thinking about what your data means. So let's start off with the effect size calculator. Currently, this will calculate your standardized mean difference effect sizes. So what do we need? It says that we need a CSV file. That's fine. A lot of stats programs will save as .csv. You can save as .csv from a Google Sheet or Excel or LibreOffice. Any of these other spreadsheet sort of programs can oftentimes save as .csv. What do we need next? We need to have specific data here, okay? So we need to have our mean, standard deviation, and sample size for treatment and control groups, okay? We know we have those. And last but not least, we have to label them certain things. So let's check and see if we actually have those labels there. And I've gone ahead and I've already downloaded this data set, which is, there's a link in the description. This is the same one that we used for the other study. So the first thing that we are going to do is rename things, and I've typed these in a million times, so I'm just going to copy paste. I would recommend that you do the same, and the reason is so that you don't make any typos as you are moving these over, because if you do have any typos and it's not able to find these columns, then the software is not going to work and it's going to throw an error instead of giving you the result that you want. Okay, so we're just, whoops, I missed copying one, so let's go back and we will put that into the proper column. Wonderful. All right, so we'll label our control group standard deviation here. And last but not least, our control group sample size. Make sure I don't have any errant spaces. All right, so I'm gonna go ahead and hit save, and I'm just gonna leave my data set. Actually, I'm gonna close my data set. I'm just gonna minimize it for now. Okay. So we have our data set. If you need to see a sample data file, you can go ahead and click here to see what that looks like, but it's going to just look very similar to what we have. So now our file is properly formatted. Let's go ahead and find it. It opened up on my other screen. I'm just going to double click that data and click OK. Oh, I forgot to actually, did I forget to close it? Yep, it's probably because I forgot to actually, number one, I forgot to save, and number two, I forgot to close. So let's try again. We will just click this, we will open up the data again, and we will click run. Okay, so we're getting another error. So this makes me think that I accidentally introduced a space into that. So let me go open up my data set and we will take a look. And the reason I'm including this in the video still is so that you can see what types of errors you may encounter if your data file is not oriented properly. So if we look at what the error says, it couldn't find this variable exp_sd that we were supposed to have. And here's the reason, it's this column, and as you can see, remember I had that problem with copy pasting the sample size? Apparently I just put it in the wrong column and I didn't notice. So we're just gonna hit delete there, we're going to hit save, and now we can see that this should, in theory, be properly set up. So we'll just close that again. We will go over here back to our software, we'll click browse, we'll just select the same file again. You can see it resets itself when you do that. We'll click calculate. Yay, we get our results. Okay, so it gives us lots of results here. This is really just our data file. The important piece is at the end we have these two new columns, yi for our effect size, vi for our variance for the effect size. This is what we are going to use to actually run the meta-analysis. So we're going to go ahead and click download data. And as you can see, it downloads it into your downloads folder, and I'm just going to leave it there for the sake of our purposes right now. So next, I'm going to go to conventional meta-analysis, and I'm just going to click on data formatting and see what it says. So, okay, so this is just some general rules about regular meta-analysis, practical requirements. Okay, I know these things already. Okay, down here to the sample data table, note that effect size number column is not necessary. Okay, I can ignore that. However, you should have a study column with author names. Now, I don't know about you guys, but I don't remember if I actually have a study column with the author name. So what I'm going to do is I'm going to go here and I'm going to click this and I'm going to open up that data file that I downloaded. Oh, and it's a good thing I did, isn't it? Because look at that right here. It says study author. It shouldn't say study author. It should say study with a capital S. So we're just going to make that correction. And I'm just going to hit save. It's going to continue to live in my downloads. I should mention that like it's probably not good practice to keep your data files in your downloads folder. I'm just doing that for the sake of this example, so I don't have to go navigate through a bunch of folder structures and stuff in order to try and find it. So anyway, you can see that I relabeled this as study. Then we have a bunch of moderator variables. Then we have our treatment group information, control group information, and last but not least, our effect size and our effect size variance. Okay, so we got all our information properly formatted. Let's go ahead and run our meta-analysis. So all I do is click Browse, and I go back to my data, which I need to remember I put in my Downloads folder because I was lazy. Perfect. Okay, so I uploaded my data. You can see it worked. I'm going to click Run. Boom, done, got our results. First thing I would recommend doing is clicking download results. That way you don't lose them, right? So that's just gonna throw that into your downloads folder for you when you do that. Okay, so when I look at what I actually got as a result here, you can see our overall estimate. This is our overall effect size, 0.61, which if we recall, a standardized mean difference. So this is between moderate and large effect. You can see from our p-value that this is statistically significant, and our confidence interval ranges from 0.39 to 0.835. Next, I would personally look at the test for heterogeneity. You can see it is significant, so we know we have some heterogeneity in our sample. After that, I would look at I-squared. We can see that it is 73.5%. This is very, very close to being considered high heterogeneity. If I remember correctly, the cutoff for that is about 75%, so right up there. Last but not least, I would look at tau squared, which is our true heterogeneity or between study heterogeneity, and you can see that it's 0.237. Now, a common question is, well, how do I interpret that? That is the same effect size type as your overall analysis. So we're using standardized mean difference here, so this could be interpreted as a standardized mean difference effect size. So 0.2 would be considered a small effect size using that metric. So last but not least, the last thing I want to point out here is simple meta-analysis only does random effects right now. I did not build in fixed effects, and that was intentional. The reason is because in my field, most of the time I see fixed effects used, they shouldn't have used fixed effects. Instead, they should have used random effects. So I only built random effects in here to try and prevent people from using the wrong type of analysis. So just know that if you need to use a fixed effects analysis, simple meta-analysis currently, as of the time of filming this in September 2024, is not the software you want to use. Please leave me a note. If you really, really, really want to see fixed effects in here, just make a comment and maybe I will at some point get around to doing that. I just don't like encouraging people using the wrong statistics. So, okay, last thing here, it says method notes. We used random effects conventional meta-analysis, and we used restricted maximum likelihood estimation. Okay, so if we scroll down, you can see that we have our beautiful forest plot. We can download this as a half page or as a full page document. And last but not least, probably one of my favorite things about simple meta-analysis is we have the R script to get these exact same results, and we can download that. So if somebody else wants to replicate your analysis, or if you want to be able to have the data to actually go with your paper, then you can, if you want to actually have the code to go with your paper when you submit it, you can just download the R script, and this is how you get these exact same results that you've seen here on the screen. Okay, so we have run our overall meta-analysis. Now I like to check for outliers and influence. So again, all we have to do is upload that same data set. So I'm just going to go ahead and do that now, and I'm going to click Run. And for a conventional model, there's actually this really nice thing built into Metaphor, the influence analysis, and it's going to give us a whole bunch of different measures. I'm not going to go through all of them right now, but the important piece that I want you to be looking for is this final column, INF, and here you can see there's an asterisk, which means that something along the way here was significantly influential. Okay, so from that, what I would typically do is I would go look at my data set and I would see which study is this, which study is on row 9, and I would look to see first and foremost, do I have any typos in my data set? Because oftentimes I found that if I have something that is influential or an outlier, maybe 20% of the time it's because I made a typo. right? And so I go back and I check that if there was a typo, then I start back over, right? I restart everything after fixing the typo. But if I don't, then I start analyzing the study. What is different about this study than the others? Does it matter necessarily that it is an outlier? And what I mean by that is, for me, as of the time of recording this, personally, I don't like to remove outliers or influential studies if they were what I would consider to be a valid study. And for me, what I consider to be a valid study is a study that seems methodologically well done. It is consistent with the rest in my analysis. And so I can't really come up with a real reason other than some statistics here why I should change that value. So I would leave that value the same. With this data set anyway. So I know the studies in this data set because I did a meta-analysis on this a few years ago with a larger data set, but this is a piece of it. So I know there's no typos in this data set. I know that the study is rigorous and well done and methodologically consistent. So in this case, this is good contextual information, but I am not going to actually change anything because of this. What I am going to do is I would just click download and I would save this so that I have it for later. Last but not least, I would also scroll down to the end of the page where we have the R script to run this same analysis, and I would just click download, and then that way I have that as well. Okay, so we've run our analysis, and we found that we have one study that's potentially influential. When we looked at it, we decided not to change anything. So the next thing that I would often do in my workflow is do a categorical moderator analysis. So again, I am going to choose my data file. Same one as before, and you can see as soon as it uploads, you get this drop-down menu, and this is basically displaying all of the columns in your data set. Now, for me, I know which ones are which, right? And you would want to know this before you start using this software, because this particular page is only for categorical moderators, okay? So I know that grade range, in my case, is a categorical moderator. So I'm going to go ahead and I'm going to hit run. And you can see I have this beautiful table that has automatically calculated a number of things for us and formatted a number of things for us. So if you know Metaphor and you are familiar with it, or if you have watched the video on how to do this in R, you will have seen that when we're doing a moderator analysis, we actually need to run 2 different models in order to get our full set of results for a categorical moderator. We would first run it with the intercept so that we can get the test of moderator, which is right here. Test of moderator. As we can see, this is not statistically significant, so we know that there's no difference between these levels of the moderator. Now, if you watched that other video series, you probably noticed that there is not a column labeled intercept here, and that is because this data in this table is coming from the model without the intercept. So if you do want to download the full result straight from R, you can do that. Just one-click downloads here to get those, the one with the intercept, the one without the intercept. Or if you want this table completely ready to go for your paper, formatted exactly as we often see it in papers, at least in my field, then all you got to do is hit this download formatted results as table. It's going to download this CSV file for you. I do want to mention a couple other things that I built into this to try and help everybody as a researcher and save them some time. So first, see we have this column NEXP. This is the sample size of your treatment group for each comparison. Next, we have NControl, which is the sample size of your control group for each comparison. Next, we have KComp. This is the number of comparisons for each level of the moderator. And the rest of these I think will be familiar to you if you're doing a meta-analysis: standard error, z-value, p-value, lower confidence interval limit, and upper confidence interval limit, and these are 95% confidence intervals. And last but not least, we have our residual heterogeneity. So as a reminder, what we're looking for here mostly is this p-value, and if this is significant, then we know that there is variance in our analysis that our moderator does not explain. So in this case, it would make sense that this is not significant, right? So we know our moderator is not explaining the variance. There's something else that is explaining it, as we can see through residual heterogeneity. So we have some notes here about the methods used, and we have some basic interpretation tips. And then last but not least, we also have the R code. So you can just download this R code so that you can provide this with your paper to replicate it. And this will be different. So I know this probably looks relatively generic, but as you can see, it is saying what data file you used, and then it is also saying which moderator you used. So oftentimes we end up running this with multiple moderators, right? So like the first time we might run it with grade range, and next we might want to know, I don't know, study settings. So we'll click that, we'll click run. It's going to run everything for us. It gives us this beautiful table, and we can scroll down, and when we check our R script, you can see now this says study setting instead of what it said before. Okay, so next we're going to go to our continuous moderator analysis or single variable meta-regression. Again, we're going to choose our same data set. I only actually have one variable in here that's continuous, which is this one labeled CONT. So I'm going to hit run, and you can see we get our result here with our intercept as well as the variable itself. So I'm going to check my test of moderator. It is not significant. And when I check my residual heterogeneity, it is significant. So essentially what we're seeing here, we are not seeing a significant influence of our moderator. There is something else in our sample that is explaining the variance. And of course, we get our R script down here that you can download as well. And just like before, we can download these results as a table, or you can download the intercept model for this analysis. Okay, next one is multiple meta-regression. This is pretty cool. This was a really fun page to build actually because I had never actually used this in one of my own analyses before, but I had wanted to. So this was a way for me to be able to do that. So I'm once again going to select my same data file. I'm going to say I have one continuous variable and two categorical variables. And you could select up to 20 of each. I don't really see a scenario where, at least in my field, where people are going to be doing that, but you know, it might happen. So I'm going to go ahead and click this. My next option is to select my variables. So I'm going to choose continuous as my continuous. And under categorical, I'm going to choose grade range, and I'm going to choose study setting. Then I'm going to hit run. Okay, so we get much longer results here, which of course we can download, but you can see it's a mixed effects model. We get our test of moderators here. We get our residual heterogeneity here. So interestingly, I don't know that I've ever actually run this particular analysis before, which is why I said interestingly. But interestingly, you can see this is just a squeak under 0.05. So this would actually be significant, which is a little bit surprising to me given the sample, but that's okay. And then up here, you can see there is variance in our sample that is still not being explained by these moderators. Okay, so we have the rest of our information down here. We have our intercept, we have our continuous variable, and then we have each one of the levels from our two different categorical variables. I think I mentioned it already, but just in case I didn't, you can download your results here. And last but not least, we have our beautiful R script. So if we need our R script, we can go ahead and click download. Okay, so we're now to step 4, publication bias. And let me see how we're doing on time. Oh, we are doing great on time. This is so much shorter than the videos on R. Okay, so let's go ahead and look at the publication bias analyses. So uploaded the data set, click run. First, we get our funnel plot. You can go ahead and download that by clicking the button. And what we're looking for here in the funnel plot is any notable asymmetry is what we'd be looking for. This is relatively symmetrical in my opinion, but you can see there's definitely a little bit of a gap here, and this guy doesn't really have anything on the other side, and then there's a little bit of a gap up here as well. Okay. So when we get down to trim and fill, you can see that there are 2 studies that were estimated to be missing on the right side of the funnel. So I guess our hunch was right. That's somewhere over here on the right side. There is something missing probably. So if we were to impute those studies, and this is what the overall meta-analysis would change to, 0.67. So this is a little bit different. I believe our overall effect size from our analysis was 0.61, 0.62, somewhere in there. So if that's the case, we're talking about moving by 0.05. So I don't consider that to be a particularly notable shift in this context, but perhaps for your context it might be. So that's why I think this is a really nice analysis. It tells us how many studies were estimated to be missing, and then it will also rerun the overall meta-analysis and give you the rest of the statistics to go along with that if those had been imputed. So if you want to download that, you just go ahead and click download. Next, we have Egger's regression, and here really what we're looking at is the p-value, and this is looking for funnel plot asymmetry. If it's significant, then we know we have significant asymmetry. This is suggesting that it's not, but we can go ahead and download this. Last but not least, we have 3 different variants of the fail-safe end test. You can see using Rosenthal's method, we would need about 1,000 studies to change the level. And then if we go to Orwin's, we would need about 27. And if we need Rosenberg's, we can see we would have 700. So you're probably noticing that I'm just skimming over these fail-safe ends, and that is because I don't particularly like them very much, to be honest. I think they are good contextual information, but I guess I can talk about that a little bit as a whole right now. So the way that I view publication bias here, and the reason I included all of these tests instead of just my favorites, were that I view publication bias as contextual information about my sample. And I think the more that I know about my sample, the better I can speak to what the findings mean. So I tend to focus personally, I tend to focus mostly on the funnel plot, on the trim and fill, and on the Eggers regression. I might report the failsafe end, but I tend to not dwell on it too much. I've seen a good amount of don't necessarily want to use the word criticism, but discussion about if different failsafe end measures are good or not great, or if they're good at some things but not others, or in what situations are they useful. And to me, that's just, I don't like saying any one metric tells me I have publication bias or don't have publication bias. I like to look at it in a holistic fashion. So they're all here. You can download all these results. And then last but not least, you can download the R script to run all these same tests here. So all right, that runs us through from start to finish an entire conventional meta-analysis in simple meta-analysis, and by my recording clock, we are just about at 20 minutes, and that was with me explaining absolutely everything in here. So if we were doing a speed run, and what I mean by a speed run is like somebody who knows what they're doing and knows what they're looking for and knows what variables they're using, we could have got this done way faster, right? But this whole video explaining how to go through and calculate our effect sizes, format our data set. We then had to make changes to our data set just to make sure it would work, but we did, and it was very simple. And then we ran our analysis, saved the results. We checked for outliers and influence, understood what that meant, saved our results, downloaded our R scripts all along the way. We looked at a categorical moderator, we looked at a continuous moderator, and we did a multiple meta-regression, and last but not least, we ran 5 publication bias tests. We did all of that in roughly 20 minutes with explanation. So personally, I think this is very quick and easy. I would appreciate any feedback you guys have on this. If you would like to see anything added to simple meta-analysis, or if you have any questions about how something works or why something works a certain way as it does, please feel free to leave comments, and I will do my best to reply to them. Otherwise, I hope you guys enjoy the software, and if you do find any issues or run into any problems, please just let me know and I will try and get them fixed. So thank you guys very much. I hope you have a great remainder to your day, and good luck with your meta-analysis.